Cetos water.
Wow, what a great presentation set. We're honored to be included. For the last century, industry growth was dependent on two fundamental assumptions. One, that fresh water is abundant, and two, that disposal capacity was effectively infinite. That world no longer exists. Today, we have three things that are happening simultaneously. One, freshwater access is becoming more constrained. Two, disposal capacity at the same time is tightening. And these two factors are happening just as we're stepping into one of the largest industrial building cycles of our modern history. This isn't just an ESG risk. When you think about it, AI needs data centers. Data centers need power. Power needs copper. Copper needs mining. All of it needs water. And both the water supply and disposal pathways we have are declining. And this represents $5 trillion in economic activity that is starting to be represented today in operational shutdowns, regulatory fines, rising treatment costs, permitting delays, even stranded assets. I'm Shannon Nee. I'm the founder and CEO of Cetos Water, and I'm here to tell you how we're transforming hypersaline and really complex wastewater to unlock freshwater resources, minimize the burden of brine disposal, and generate critical minerals for a more circular water economy. So the problem with today's treatment stack was it wasn't designed for complex industrial brines. Membranes, while they are a great part of the treatment train, they struggle at high salinity conditions. Essentially above a certain salinity ceiling, they clog. Thermal evaporators, while they work for complex brines, they're very energy and capital intensive, boiling water, capturing the steam and recondensing it. And solar evaporation is very limited in the deployment opportunity and most importantly recovers no water. We have developed a completely novel way of doing desalination that's both membraneless and non-evaporative. You can think of it like a liquid sponge. At cool temperatures, around ambient temperature, our liquid sponge absorbs fresh water and definitionally rejects everything else. We then take that soaked sponge, moderately warm it up, and at higher temperatures, the sponge wrings itself out, generating fresh water for use, and then a solvent that's 99.9% recyclable. So some of the key takeaways relative to the conventional treatment stack is because we don't have a membrane limitation, we can treat across the entire salinity spectrum, up to and past the point of solids handling. We can customize water recovery up to ZLD and require no chemical pretreatment. And because we have a small thermal footprint, we can tap into industrial waste heat where it's present, delivering a far more cost-effective solution relative to thermal evaporators, and we get to sidestep the corrosion-resistant CapEx that drives up these system costs. And so in terms of the economic impact that we deliver, on the brine management side, as I mentioned, 70% less energy intensive and over 40% less capital intensive than thermal evaporators and crystallizers. If you think about that in the context of some of our customers for produced water in some basins, we can undercut the costs of disposal by a third and still maintain 50% profit margins. We can also use our technology for brine concentration in evaporative mining to increase the amount of throughput and the resource recovery on the exact same physical footprint while recapturing fresh water that's otherwise lost to evaporation, solving their biggest government pain point. We also have specific mineral recovery capabilities to precipitate magnesium and calcium as a standalone or a complement to our classic water extraction process. One of the reasons why we're generating so much traction is because our technology works on real complex feedstocks, ranging from produced water to mine tailings, ARD, irrigation drainage, flue gas, the list goes on. We recently received an ARPA-E Recover grant to transform produced water into freshwater resources and critical minerals, and we're recognized by Wheaton Precious Metals as the most exciting water technology in mining, winning a $1 million award. Right now marks a very exciting time for our technology as we've officially transitioned out of the lab and last week commissioned our fully continuous multi-stage countercurrent extraction process to process 200 liters of brine a day, and we've done so in a year and under $1.5 million. But what I'm most proud of as a CEO is the team of people that I have sitting around me. an interdisciplinary team with scientists, engineers, and some of the best advisors in the game. So if the last wave of industrial growth was defined by abundance, this next one will be defined by scarcity, and we are developing the infrastructure layer to support that. Thank you.
Okay, questions?
Thank you for the presentation. It's an awesome technology. It seems like that your solvents are an important part of your solution, and it recycles within the unit. But for the feedstocks for your solvents, have you locked in suppliers so that you can scale up economically?
Yeah, so what's great about our liquid sponge, our solvent, is that it's based on commodity chemicals. So we don't really anticipate any supply chain risks because there's a number of suppliers that we can reach out to.
Great, thank you.
Yeah, thank you again. For all those potential treatment applications, those are all coming from quite different industries. How are you hierarchically looking at that, and how are you going about prioritizing in your next phase? Yeah, that's a brilliant question. And so one of the blessings and curses of our technology is because we extract the water, we can treat a very wide range of feedstocks and even handle the variability within a customer. Right now, as we are bringing this pilot system online, we're trying to showcase to investors that this is truly platform technology that we can handle with the same precision and water extraction and salt rejection, everything from flue gas to produced water to really concentrated mine outputs. When we think about commercial